Oh, there.
Yeah. Hey.
Hello, my friends. Put over here. I don't know how it shows up on your screen. Like, can you see all this stuff on my screen? Yeah, that's not good. All right, so I'm gonna close. Wait, I don't think I can close this. Maybe I could just minimize it somehow. What if I hit? I don't think I want to exit. All right, I'll just move it over here into the little corner, so I won't see any chats or anything. Um, and I think if I go like this, oh well, I'll go back and forth. Good to see you. Okay, are we ready? Shall I just go? Can you see everything? All right, great. Hello, friends. Good to see you, everybody. I wish I was there again. Actually, was almost in a couple weeks ago. I was supposed to go to Goa right around election time or something. Anyway, it didn't work out because the tourist or the visa they told me to get wasn't the right visa. Anyway, it all got canceled and I didn't get to go, but it was very good though because I was going to be there, I think only for 72 hours, and it would have taken me 72 hours to get there. So that would have not been very fun for anybody. But next year, I'm going to go for like 7 days. So I look forward to that. But welcome or hello, welcome. I guess good morning. It's evening, of course, over here. My name is Noelle Lacharite. I think I've seen some of you before and have met some of you before. Certainly, if you are not connected with me on LinkedIn, feel free to do that. It's just my first name and my last name. You can also connect with me at Microsoft. It's just my first name dot my last name at Microsoft, and I'm on Twitter. As a matter of fact, today we made a huge announcement. We have a big conference coming up in at Microsoft called Microsoft Build, and I am the AI Dev MC. And what that means is that I will be basically providing commentary and curating a list of sessions that I will cover in detail, in depth, that will make sure that people who cannot come to Build get a in-depth understanding of kind of the content that was covered. I will also get like sneak peeks to the slide decks. I will talk to the speakers. So if you want, you're welcome to follow me for that. It'll happen. Most of the content will be on Twitter and LinkedIn. I will also be cross-posting to Instagram and Facebook. But the source of the content, I will be doing a lot of LinkedIn live sessions. Obviously, the timing may not be great because it'll probably be in the evening or middle of the night for you guys, but I definitely wanted to let you know that. So this is me. I will toggle over to my presentation. You can see here, this is my family. I have 4 children, my dad who lives with us. Um, and I'm in a situation right now where I am constantly, as I'm a software engineer by trade, and I'm constantly given ideas based on my dad living with me and my son, who's my oldest son, he's 14, has Down syndrome. So I'm constantly like, how can I make the world accessible to both of these audiences? So you'll see or hear a lot of that accessibility kind of seep into the things that I'll talk to you about over the next 30 minutes or so. I am actually just got a new job at Microsoft. So my new role is I'm a principal program manager. So now I lead a team of people. And I'm focusing on enterprise voice through Cortana. So Cortana, I know many of you probably know the name and have maybe wondered what was going on with Cortana. So I'll be part of kind of um, the new I guess, evolutionary step that Cortana will be taking to help with task and process automation. And so, like I said, just follow me on social if you want to kind of keep up to date with those types of things. But today I'm going to focus on sharing with you, some of you who have seen me speak before, I wanted to show you some of the latest and greatest things that are going on with AI and really help you understand how Microsoft is thinking about artificial intelligence. So as you know, we actually have a huge campaign going on in the United States right now called, it's basically our AI campaign. And there's an actor that's very good and inspiring. And basically, the truth is that we our technology is now no longer the barrier to doing the things that we want to do. So in the past, software engineers like myself would get an idea, and then we'd be like, oh, if only the technology could do the thing that we're thinking about. And oftentimes in the past, the technology would actually be our roadblock, right? The fact that it wasn't evolved or wasn't in a compliant environment, or didn't satisfy certain regulations or certain compliances in government compliances. Uh, and now that's really less and less the case. We have more power than ever, than generations that have come before us. We've got just incredible capabilities because our software has now evolved and is evolving so rapidly, that really we have the ability to change the world, right? We can go in and identify a world problem. We can say, great, let's leverage AI to do this. And in some cases, we don't even need to build the model from scratch. But before we dive too deep into how we can solve the world's problems, and most importantly, how we as software developers can help companies do this, let's first take a look at kind of our umbrella. So this is like the big umbrella of Microsoft AI. So it's important for you to know that Microsoft AI is not a thing. You cannot download it. You can't buy it. It's an idea. And this idea is decades old, 25 years old. It's actually quite longer than that, but Microsoft at least, its teams have been working on these models for at least a couple decades. Honestly, the idea of AI in general, right, stemmed from 1950 when Alan Turing did his Turing test and said, how much, what software, what do I need to do to this software to make it indistinguishable from humans? And all of these were based on, again, more ideas than actual, products. So I want to share with you kind of how these ideas have evolved and how our products at Microsoft have evolved as a result. So Microsoft AI, big thing, big idea. It starts off on one side with what we call pre-built or applied AI. Now, pre-built AI are very specifically models that were built by Microsoft, right? Microsoft did all the work of collecting, right, collecting Microsoft data, doing all the work to not only wrangle that data, but then, annotate the data, identify features in that data, create and select the algorithm that they'll use to do whatever they want to do, right? Whatever prediction they're trying to make with that data. All of this work was done by Microsoft and then exposed to developers in the form of web services. You're going to see a little bit more about this, I think, in other speakers today. On the other side, though, we have what we call custom built AI, or AI that you build from scratch, right? This is where it's your models, right? You are going to build the model from scratch. You're going to use Jupyter Notebooks or R or TensorFlow or whatever your tool set might be. And you're going to create the models. And most importantly, you're going to use your own data, hard-earned data today with rules and regulations like GDPR, making it harder and harder to curate data that we need for these models. So what we want you to do is really, as a software engineer, we want you to know the difference between the skill set that's required to build custom models and the skill set that's required to do everything else. So what Satya Nadella did was think to himself, or really think on behalf of customers, what's the best combination of these two things, right? Usually if you start using a pre-built model, you kind of hit a block, you kind of hit a wall where the data that model was trained on doesn't solve your problem, right? Where you're like, oh, I'll give you an example. I don't know if I showed you guys this, but I built a custom vision model to detect the difference between two Disney characters, right? And when I built that model, right, there were two Disney characters, and those basically, when I ran that through a pre-built model, it didn't know that it was Disney. It didn't know that they were characters. It said like stuffed animals sitting in a room or something like that. So the model got me close, right? It said, I think it even said like mascot. It was close, but it wasn't specific enough to solve my problem. Now, until a few years ago, the only other option I would have had was to get ResNet 50 and go build my own computer vision model from scratch, which is a lot of work. and takes a really long time to get to a point where I can leverage it. So what Satya Nadella said is, wouldn't it be great if we could take Microsoft models and build what's called customizable AI, right? We take Microsoft models, we give you the benefit of Microsoft models and allow you to then transfer learn on top of it in order to create a new model. So you then add your data, right? So it's like the best of both worlds, right? You don't have to build a model from scratch. Start where Microsoft left off, use that as a baseline, and then once you've got that baseline established, now all you have to do is add the delta, right? You have to add the delta in images. So like 15 images tops to just get the model trained and understanding the nuances of your specific data problem. And of course, when you combine, right, Microsoft models with your data, right, good stuff happens. Happiness ensues. People don't have to do as much work as they used to. And you get to stand on the shoulders of giants, right? Stand on teams that have been working on this for decades. You now get to pick up where they left off as opposed to trying to start that work from scratch. So we call this democratization of AI or commoditization of AI, because all of these pre-built models that I'll share with you in just a second, all of these pre-built models really represent kind of the foundation of models that no one will really build from scratch anymore. Things like computer vision, facial recognition, natural language understanding, right? The base of that will be established by large companies like Microsoft, and you will just want to build on top of them. You don't want to necessarily go and build an entire computer vision or facial recognition model from scratch. That's no longer the game that we're trying to play. So what I want to do here is just show you an example of a couple of our models in action. This is a financial services example. I hope you will be able to hear the audio loud and clear. You'll have to let me know. But well, why don't we just take a listen and then we'll talk about what we've heard. Here we go.
Hi, can you give me a quote in GBP US dollar, please? 139.25.28. Can I buy 5 million GBP US dollar, please? Yep, filled at 139.28. Thank you very much. Done. Bye.
So what you could see happening here is that you have, right? What we just saw was a transaction that happens on the floor of stock exchanges all the time, right? And on the floor of these exchanges, what usually happens is they have this conversation and then they have to go write it down. And in the process, and this is of course on the floor with hundreds of other people doing the exact same thing at the exact same time. So it's extremely loud, extremely chaotic, and prone to human error. So what would happen if we started to introduce technologies like speech to text, right, to transcribe what's being said and provide a way for the different participants to simply validate what was said, as opposed to actually having to scribe it all down on a piece of paper and then type it back in to a system, right? So our goal in these types of solutions is literally to look at human error, find out what's the typical human error rate that currently happens in this system. And our current version of like the Turing test, if you will, is can we beat human error? Can we even get close? Because if we can get close, it might make more sense for us to let a computer do that work and let a human validate it, as opposed to letting the human do the entire thing. So this is just one example, but this is leveraging, right? You can see here, it not only leverages speech to text to turn it into text, but then it leverages text analytics to actually identify the most important entities, and from those entities actually create an intent structure. And that's the intent that actually turns into a sell or a buy action. So very, very cool. The idea here, of course, is that it doesn't then, the machine is not making the decision to do the buy or sell. As you saw, right? We did the transcription, they read it, and then they had to go up, drop down from the list. A human had to actually do the transaction. But it is much faster and much less error prone when you have a machine do that kind of mundane task of just simply transcribing. Way better use of time than having an individual on the floor trying to scribble it down on a legal pad. This is this has been proven to be much more performant. So just to give you an idea. Now, last time I talked a little bit about this, but I always want to make sure that if there's anyone in the room that's not familiar, that we, give Azure platform its due, right? So, of course, I've been talking, we just saw a little bit about using some of our cognitive services. We have about 30. I'll show you those in just a second. These pre-built AI services exposed as as web services. Satya is very passionate about creating a conversational interface for any software that we build, which is kind of interesting if you think about it, right? We're Microsoft, Windows. We taught the world, Windows and drop down and navigation and menus and buttons. Like that was Windows taught the world that. And now we are shifting a little bit to say, okay, yeah, sure, you can do that. But what happens if all that goes away? What happens if we have no screen whatsoever? How can we enable people to communicate to our software just through voice? So conversational AI is really speaking to that component. Bot service now is the underlying framework for almost all services that use voice within or use speech and natural language within our architecture. And then, of course, like I said earlier with the umbrella, there is custom AI and Azure ML that can be used specifically, and this is important if you're going to write down something, this might be one. Specifically, we have a new service called Automated ML. The reason for this, and I'll just give you a quick example, I talked to a lot of executives in what we call executive briefings or meetings where I come in and speak to the highest level of organizations. It's very similar to what I'm doing for you right now. And I went into an organization and they were based in Kentucky, which is a very, I don't know if it's small, but it's definitely a not well populated state. It sits in the middle of of the state. So there's no, you can't get to the ocean. There's no mountains. Like it's not, it's Kentucky. And what they said to us was, how are we going to recruit machine learning experts that are going to do this incredible machine learning work? How are we going to recruit them if companies like Amazon and Microsoft and Facebook, right, Apple, they're going to take all this talent? And mind you, I do still think there are people that just like to work in places like Kentucky. But in order to help with that job kind of gap, which I don't know if you're familiar with it, it's huge. We have millions of jobs that need to be filled in the next 10 years, and we have hundreds of thousands of people that are going to be capable to fulfill them, which is not good. So there's a huge gap. So in order to solve that gap, what Satya Nadella encouraged us to do and what the platform ended up doing was providing a tool set called Automated ML, which allows you to take younger or less experienced data scientists and walk them through the most difficult processes in data science. Things like, how do you take a data set and make it decent enough for a model to be able to use, right? How do you make sure that you've identified the feature set correctly, annotated it correctly? Most importantly, how do you make the right choice based on algorithm, right? There's so many algorithms to choose from. How do you know if you're using the right one? So now we've applied AI to solve those problems and really helping younger or less experienced data scientists do even more. Now, all of this, of course, sits on top of Azure infrastructure. So we want to make sure that we share with them or share with you what's possible. I'll give you an example just to illustrate this infrastructure that you want to be thinking about. We have an organization or a company, a partner that worked with us. They had their engineers just a few years ago. Their engineers were using their eyes to examine hardware. Literally, they'd look at hardware and go, that's good, that's bad, that's good, that's good, that's bad, that's good. They actually would average about one image every 3 seconds. The challenge with that, of course, is that it's engineering time that's doing this type of decision and evaluation. So what would happen if you introduced a machine learning model to do some of that work for you? So they created a cluster of CPUs, about 12 CPUs in this cluster, and they basically ran this standard ResNet 50 trained computer vision model as part of cognitive services. And they were able to actually get to about 12 images a second, which if you think about it from the engineer's perspective, that's amazing. They got hours of their day back. Literally, I think it was like 2.5 hours of their day was returned to them because they no longer had to do that manual analysis every day. But then they said, wow, that was amazing. We've got all this benefit. How do we make this even more productive? So increasing their hardware, they went to GPUs and they got into the double digits, right? 50, 60, 90 images a second. And then for very specific use cases, you can procure hardware that will allow you to, and again, it does have to be for a very specific type of workload, but you can procure hardware that allows you to achieve, in their case, 900 images a second, right? 600, 700, 900, depending on the kind of work we were doing and the type of resolution that we were dealing with. That's incredible, right? This literally moved them ahead months in their schedule, years over time. Huge amount of opportunity was provided to these engineers who no longer had to use their visual eyesight in order to determine what they were, in order to figure out like their work. It was, they were, the engineers were much, much happier not having to do that work, but B, the engineering time was now freed up to actually build better software, which they did. So lots of good stuff come from that. We, of course, want to remind you that we have AI tooling for wherever you are as a dev. So if you are a machine learning engineer and you like using, Jupyter notebooks, or you like using TensorFlow, or you like using scikit-learn, right? You can pick your algorithms, you can pick your framework, and all of those things will run in our tool set. But most importantly, I didn't mention it, but we have a really cool, and this is another point to write down. If you don't know about this, this is extremely important, is this concept of being able to port your models from one platform to another. So back in the day, we had this concept of vendor lock-in, where when you picked a vendor, we would do as much as we could to lock you into that vendor platform. Satya doesn't agree with this, right? He wants you to have freedom to move and really put the burden on us, Microsoft, to build a better platform that you choose to be on. And so there is a transformation layer, if you will, called Onyx that you can use to basically create a portable model that you can port from one platform or tool set to another. So Onyx, ONNX, is something you'll want to look up if you haven't, if you're not familiar with that term before. And then the last thing about that I want to mention is that with all these tools, another evolution of thought that came to our leadership team was, how do we make it possible for you to run, think about it, if you're a space administration and you're doing a lot of data processing on cameras that are actually mounted on satellites in space. It's pretty hard for that satellite to beam back to Microsoft Cloud in order to do data processing. It's impossible, to be honest. I think, for example, NASA has a device on Mars. It takes 19 days for that data to go back and forth. So obviously you're not going to go back and forth to do data processing with that amount of latency. So how do you solve for that? Well, what we decided to do, and it sounds crazy in the world of models, but all of these models are now deployable as containers, Docker containers, if you're familiar with them. There's a couple great blogs on them now. I think I did a YouTube video recently about it, but you now can deploy language, Lewis, computer vision, I think there's another one that I can't remember, but there's 5 models that you now are able to do this with, to deploy them as containers. So if you think about it, this is like being able to deploy a container that has a computer vision model in a camera mounted to a car. And now on the car, you can do processing before it ever hits the cloud. This is something that's very valuable, especially from a cost perspective, but it's also reducing the amount of churn back and forth with data that's not actually necessary, right? Why even transport data across the network if you know you don't need it? And today we don't. If you don't have this kind of at the edge, intelligent edge solution, you'll be kind of required to get all the data back and then make those decisions, right, as instead of at the edge, you'll be doing it at the point of origin. So a little bit more expensive to do it that way. So those are just a couple tips, right? Onyx for platform independence, and then containers for at the edge computing with are cognitive services. I think that's it. And then I have one more little surprise for you, for those of you who've been building with cognitive for a while. So if you are a dev, one thing we try to say is AI for all, right? And really what we mean is that we want to meet developers where they are with the language that they're comfortable with. And if you are comfortable with Java, great. Here's an API for you to access all of these models as a Java programmer. Or if you're comfortable with Node or Python, right? We want to meet you where you are. So there are APIs for all of these. Now here's the magic slide, which most of you have seen before. But this is my hope in showing you this is that when you look at this, you would see, or more importantly, when you see a business problem or you see a challenge that you are being met with as a software engineer, you would first think in your mind, right, now that you know what these are, you would think, oh, is there a pre-built model that I can use to solve that problem, right? Going back to that umbrella, you always want to start with like, can I solve this as a software engineer first? If I can, great. Am I restricted because maybe the model doesn't have the right data? Now maybe I can customize that model, which would be great. Or maybe more importantly, I need to actually build it myself. Maybe I need to create a new model because no model exists that solves this problem. What we want to do is just make sure that that model development team, right, the machine learning organization, never gets tasked with doing things that are commoditized. Hopefully that makes sense, right? We never want a team building a model from scratch if that model exists on this list that you're looking at. So really important. Today, that's not always the case. I've had many conversations where I'm sitting in the room, right, talking to the devs, telling them about here's all the stuff we've commoditized, and there's these awkward look on people's faces, and they say to the CEO's like, didn't we just spend 600,000 on that thing? So you don't want to be in that group, right? You want to be very clear, what can you build on versus what do you have to build from scratch, and keep them very separate from a resource perspective so that you're not wasting time, effort, energy, and money. So let's take a look. Before I do that, I'm going to show you right now just an example of this kind of end-to-end solution that Satya envisions for our software. But before I do that, I need to kind of set the stage a little bit. So the first thing I want to mention to you about this demo that I'm going to do for you is that almost every company that I've encountered has massive amounts of data. It may not be the data they want, right? But they have massive data because about 10 years ago, we all got into big data and we all started saving every server log file, every receipt, everything that we've got. And so that being said, we have this, huge collection of data on the planet. Now, let's call it like the world's data. Now, 30% of that data is indexed by, Bing and Google, right? Publicly accessible data. However, the rest of it is locked inside of enterprises, and most enterprises don't have the machine learning teams that they need to be able to even process it. So what Satya asked the Azure organization to do was create a mechanism that allowed developers, software engineers within a company to unlock that data. And I'm going to show you an example of how that works. And it's not enough just to unlock it like in, a web application, which I will certainly show you. We also need to think, how do we create a custom, how do we leverage speech and natural language in order to really open up that data to be queried just with your voice, just by asking questions. So I'll be showing you that as well. So let's take a look. Hopefully I've got it up here somewhere. Let's see, over here. So there is a really cool site I want to turn your attention to if you've never been there, called AI. Maybe I'll open it up in a new tab. It's called AI Lab, right? So if you go to ailab.microsoft.com, it'll take you there. The reason this is cool or interesting, at least to me, I learn by doing. And so when you learn by doing, it's you need really good samples. And these are incredible. So if you scroll down, you can kind of see all these projects. But the cool thing about these projects is that they all are fully documented, and all source code is available in GitHub. So if you're a dev, my first thing I did when I got here and found out this was I went and rebuilt all of these, right? Just build them. And just by building them, you create this really incredible muscle memory and skill set that not many people have. So just take a look at some of these. Specifically, I'm going to look at the JFK files and talk you through that, but all of these are really great examples. Some of them I even used today. Okay, so JFK is one of these. As I mentioned, all this code is available in GitHub. This thing I'm about to show you, this solution, can actually be implemented by anyone, right? So this solution can be implemented by any company. I'm going to show it to you from the perspective of like a government organization, but the source code can be customized within about an hour to fit any company's needs. So let me launch it and you'll see what I'm talking about. So the concept here is that there was an assassination. I don't know if you're familiar with American history in this way, but there was an assassination of a president in the 60s. Big deal, huge controversy. And the government at that time ended up taking all of these documents related to that controversy. First, they kind of obfuscated it, right? They basically made it very hard to understand by injecting code words for meaningful terms within that repository. And then they, on top of that, basically hid it from the American people by making it top secret and classified information. Well, what ended up happening about 4 years ago in a previous administration is someone in that administration was like, oops, sorry, did we do that? We didn't mean to hide that from you. And they gave it back to the American people. The problem, though, and I don't know if I have one to show you, but it's basically like getting a bunch of files on a thumb drive, right, or on a flash drive. How are you going to even start looking? 34,000 docs. How are you going to even start looking at that stuff? You know, and looking through it. So this solution is leveraging a bunch of AI models, and we're going to use those AI models to actually get value and derive value and insight from this data set that was provided. And so again, you can see this like even on your hard drive of your computer. Usually within 6 months of buying a computer, especially if you're in tech, you've got things on there that you'll never find again, that you'll never be able to locate again because you can't remember, right, what PowerPoint deck it was in or what Word document it was in. It's very difficult to find out. So imagine if we're like a journalist and we want to go use a web application to solve this. You can see here I've got a very simple web application hosted on Azure, right? I'm just going to hit search, and it's going to hit what we call cognitive search, which is an enterprise index. It's elastic search. And it does what all indexes would do, right? You can see here over in the tags, it identifies based on the metadata of those files how many occurrences of this word there are. That's something, typically you'd see that in like Google or Bing or whatever. But here's where things get interesting, right? So here we're going to leverage computer vision to go in. This is actually a picture of a typewritten or typewriter document, and that typewriter, right, like a typewriter document that's not very good even if you look at it, but we were able to transcribe that and then identify the word, right, that we're searching for. Here's the really cool thing. You can even identify words that are in proximity of each other, right? So let's say let's say we've got all the documents in our company, all the contracts we've ever signed, and we want to find out where any document that has the word expires and the word, I don't know, like April or May, right? We want to find out any doc that has those two words together and maybe within 10 words of each other, so that all contracts that are expiring in April would pop up. And it's doing that without going to metadata. It's actually going into every file and looking for that data. So let me show you also, you can see here, we have the ability to do cursive analysis, right? So it can identify cursive handwriting, translate that or transcribe it also into text and do that same analysis. This is very, very interesting because it allows you, a lot of times what will happen in companies is people will handwrite things on top of documents and scan them in. sometimes what they handwrite is not allowed. Like it's PII or private information about customers, about right credit card information, driver's license, state IDs, whatever it is. And so now we have the ability to actually identify handwriting and then transcribe it and then analyze it and see if it's something we're concerned about. Now, in addition to that, just to kind of, and I'll close up with kind of the way I'd like this to work. It's a bit of a demo now, so we'll see how well it goes. But you can see here, it's also able to identify photos. Now, again, before, like this photo doesn't actually have a name on it because it's all code word based. But because this was created recently, the Face API actually recognized him as a celebrity. And you can see the model came back and said, oh, look, it's Lee Harvey Oswald posing for the camera. Now, he's not actually posing. I don't know if you know, but this is not the posing sign. This is a sign that says you're in big trouble and you're going to jail. So one thing we can think about is right now the model thinks he's posing. What could we do? Remember that whole middle of the umbrella, customizable AI? What could we do to train the model so that instead of it saying posing, it said Lee Harvey Oswald, getting his picture taken for a mugshot, having a much more detailed descriptive explanation. Well, it turns out, and I think you guys are going to do some of this in custom vision, we just have to add 15 images to the existing computer vision model. Say, here's 15 images of people with a black slate. This means they're in jail. And that will be enough to train a model on a new decision that it can make based on that. 15 images, that's it. You can do it in like 15 minutes, maybe an hour if you got really hard data that you need to tag. But pretty impressive. The final thing with enterprise search is that we provide you a visual representation. All of this is via web service, right? So you're going to pass in your index, and this is what comes out of it. So as a developer, these are all just things that I can use to help users find what they need more effectively. So you can see here we went from like 34,000 docs to over here, right? 843. That's a decent chunk. But now our goal is to say, here are the top 10 things you should look at in relation to this entity, and giving you a visual representation of what those top 10 things are, right? That's extremely helpful. But this is still rather old school, if you will, right? From like 2 years ago. So look, what would happen if maybe instead I created a chatbot, right? This happens to be, if you know a little bit about this history, Lyndon B. Johnson was the new president that was immediately elected. And in the JFK files that we had from the government, there was actually an audio, the very first audio that was captured between Lyndon B. Johnson and the head of the FBI at the time, which was this guy, Mr. J. Edgar Hoover. And so when I found that out, I was like, oh my gosh, we have to build a Hoover bot. So this is my Hoover bot. And so let me go ahead and I'm going to turn on speech and hopefully you'll be able to hear it okay. The suspense. I'm going to refresh my bot to see if we can hear it.
Welcome to the JFK files. I'm J. Edgar Hoover.
So hopefully you were able to hear that. That is a synthesized voice. So what I did is we took three audio files and made up about an hour of audio and uploaded it to basically custom voice, which is our speech synthesizer service. What ended up happening is it took the real audio of Hoover and created a synthesized voice that generated the sound you just heard. Now, I'm going to play it one more time and see if you guys can notice something interesting.
Welcome to the JFK files. I'm J. Edgar Hoover.
So if you notice, the last thing that he says is his name, J. Edgar, but he says Hoover. And Hoover is the way people would say their name if they were from New England. And in this case, he's from Boston. So I thought it was really interesting that this custom speech, right? I passed in a few files. I'm not an acoustic engineer, right? I'm just a developer. But I pass in these files and it's able to create a synthesized voice that detects, right, that nuance in his speech, which I thought was really fascinating. Now, in the spirit of time, I'm just going to show you a couple more things about this bot that I think is interesting. So you'll notice here, I'm going to say, right, like I might say, Mr. Hoover, what is GP floor? And if I say that,
Post-assassination designation. It is usually used as a slug to describe the contents of a memo as Oswald related.
wait for it. It's doing a search for me. Oh, maybe it's done. Oh, no, there it is.
I found some documents you may be interested in.
So a couple things I want to bring to your attention here as I close out. Notice here this word GP floor. This is a CIA, what we call cryptonym or code word. Now, the interesting thing about that code word is that the English language, the default natural language model, has no idea how to handle that. So I, again, had to use custom speech to train the model so that when it heard that word, it knew what to do with it so that it could then do a search within the repository for that information with no extra code. It then also did a search on it, which you can see here. So this is huge that it's able to even understand what that word is. So imagine, for example, if you have product names, service names, let's say you're an Xbox developer and you're building a new alien species and you want to be able to speak the words of that language or be able to, you create words that represent weapons that have never existed before. This gives you the ability to expand the natural language model. But do you have to build it from scratch? No, you start where Microsoft left off and just add on top of it. It's incredible. I mean, this is literally the differentiator between us and everyone else is that we not only want to give you the model, but then we want you to be able to transfer learn on top of it and own the new result. And that's one of the reasons why I came here, because that's super interesting to me. Another thing that I wanted to show you here was you'll notice there was a little bit of latency between the end of the definition and the results. I actually had to inject that latency because as you know with AI, once a model, a machine learning model, maybe you don't know, but once a machine learning model gets a certain confidence level, it knows what to do. So if, for example, it's heard a question 2,000 times, by the time you get to the fourth word of that question, it's already pretty sure it knows the answer and can actually respond before you finished asking. Alexa used to do this. Oops, don't say anything. Sorry. Oh, dear. Oh, no. Okay, stop. Oh, sorry. Okay, hopefully she'll stop. The reason I mention that is because how interesting it is when any voice device tries to answer you before you finish your question. It's a little unnerving, right? If you start speaking and it's like you're halfway through your question and then the bot answers you back. Even though it's possible, humans are not yet ready for this level of innovation. So we encourage you to think about kind of your user experience and inject latency, a little bit of latency, so that they don't, so that once your confidence level is met, you wait till all of that audio is heard before you actually respond. So that's why I demonstrated that. But you can see here, this is pretty interesting, right? It gives me the ability to use a chat service to talk in my natural language, to just type in or say whatever I want. And now it's able to do the same thing that we saw within the JFK files, right? The same thing that we saw over here, but in a slightly different interface, and one that maybe doesn't even require me to have a mouse or a keyboard, opening up this software to many, many more different types of users, different types of abilities, different types of people. So this is just an introduction kind of to all of the new things that we're looking at investing in at Microsoft. I hope you found it interesting. This project is available on GitHub. So if you want to build this bot, if you want to build JFK files, you could recreate the exact same thing that I just did for you here. You could recreate that and even customize it for your own use. So it's always exciting to talk to you. Thank you guys so much for having me. I hope like I said, I hope you got a really good gist of what we're trying to do at Microsoft AI. And I hope you guys have a wonderful rest of your day. And if there's any questions, of course, I'm more than willing to take them.
Noel, as you shared the sample which you showed us, it takes the speech as well as I think vision API as well. So do we have some kind of demo or kind of examples where we can have all the cognitive services, whether it is Vision API, whether it is speech, facial recognition, and Lewis. So can we have all those in combined in some demo or something? You have.
So, I mean, technically that's what this is doing, right? So this is right here, this is Face API that's rendering this result. This is computer vision that's rendering this result. This is synthesis, or this is custom voice using custom NLU. The sound that you heard was custom speech. So this is close. But there's, for example, if you look at, let me go back to, this is Intelligent Kiosk. These are all of the, it's very hard to create a holistic application with everything, but we did decide to create a kiosk with a bunch of individual applications in it for different experiences, right? So this is a good start. This is available in GitHub as well. I think I even have I'm just going to go over to GitHub and see if I can find it. There it is. So you can actually go grab the kiosk, but this is a Windows app with a bunch of little Windows apps within it. It's not what you're asking for, right? What you're asking for is kind of a holistic demo of like all these things working together. And yeah, what I just showed you is probably as close as we've gotten so far.
Yeah, that's true.
Yeah. But this is really cool. So if you look at this, like there's a Raspberry Pi kiosk for Intelligent Edge. But if you look at this kiosk, it'll show you these are all of the different, models basically that you, oh, that's not it. All the different applications that you can build. So you could see here, basically you could just rebuild this, and then all that code is open source. So if you wanted to use computer vision or natural language, or you could just copy and paste that code and use it in your application. So it's super useful, I think. And there's a bunch of these different samples. But yes, great question. It's definitely since I've got here, it has been my passion, and like this Hooverbot I created for exactly that reason. As I was like, well, how do we like create a end-to-end sample that shows all of these things working together? And this is as far as I've gotten. It's taken a long time.
Thank you.
Yeah, you're welcome. Any other questions? There I am.
Hello. Hello. How do you connect the file number with the host one? That file number you showed, how you can connect that this file is connecting with the host one?
How do I connect the what?
This file number.
It's talking about the file number which is getting listed.
The file number.
Yeah, file
Right.
number. So he wants to know like how that file number is getting connected with the keyword which is being posted over there. Is that any kind of indexes which is being added, or it's just an list
Oh,
of
I see what you're saying. Absolutely. So this, I mean, the bot is just an interface, but this is an actual index. It starts off as an old school index. It literally, so in order to build this on 34,000 docs, it took like 2 hours to build the index originally, which is why it's so fast now. I can search for, right, like Kennedy, right? And so so right now this is based on an actual, what we call Elasticsearch index. And what I did in the bot is simply, this is actually communicating to that index through a web service. So all I had to do is make sure that any of the entities that or any of the utterances that I created, like what is GP floor, I had to make sure that text analytics could understand that GP floor was a thing and that that was actually my query. And so you can see that the things that get passed to the query are the things that are in bold. But yeah, this is, it's all exposed as web services. So when you go into, that's a good question, actually. You could go into, it's not a cognitive service. It's actually called, let's see if it's in here. I don't think it is. But it's called Azure Search. So I think you might have to, it's part of Azure Search. So I'm just going to look it up really quick. Oh goodness, it could take me a long time. So I'm just going to Google it. Oh, maybe I'm going to look for cognitive, which is much more specific. Cognitive search. There. See what comes up. I should have put maybe Microsoft. There it is. Announcing. Nope. Actually want. There we go. So cognitive search will actually show you how to build that original, we call it document cracking, basically taking a bunch of data sources, structured and unstructured data, and create a massive index. The nuance of that is that that index is actually not metadata on files, which is what typically indexes are. It's now actually introspection into those files through the use of cognitive skills like computer vision, OCR, handwriting OCR, etc. Face API, right? And the other cool thing is that if you know a transformation that you want on that data, you actually can build your own custom skill and do that as well. So very cool. All right, great. Thank you for that question. Any other questions?
So the data is getting collected by your board applications. So this is precisely for this is all unstructured data or this is the structured data?
Is it what? Sorry, say that last part again.
So your board applications, which is getting collected the information which you are trying to say, and this after that it represents on the screen. So the data is being saved on an unstructured format or a structured format.
Oh no, it's actually so it's an index that's built on structured and unstructured data. So it's not being reformatted or reorganized into a new format. It's basically being indexed in its original format, which could be actually, let me see if I don't know if I have an example here that shows you the type of documents that we no, we don't. But it has, like, it could be Word docs, Excel documents, or I should just say Office documents, but it could also be database, it could be videos, it could be PDF files, right? So all of those, some structured, some unstructured, in their existing state, indexed at time of indexing. It doesn't reformat them or put them in a new organizational structure. It keeps them all in their existing state. So it allows you to actually do, that's why it's called cognitive search. It allows you to do real-time search over document structures that are all of different, all different types of data.
So it supports only unstructured. It supports both the databases. I mean, to unstructured and structured as well.
Yes, I'm trying to see if I have. It should be here somewhere. Where I unfortunately I don't have it up, but yes, and I will, maybe what I'll do is add a couple of visual rep to the slide deck and get it back to Kasam so you guys can have it. But yes, you could definitely have, there's a, it's not infinite, so there is a list of data types that are supported today, but that is something. There's also the ability to create custom skills, which is your ability to create a transformation layer for any data type. It just then requires a little bit more software engineering work on your part to make that happen. But the job of the cognitive search team is to make more and more of those skills available out of the box. Right now, it's, the skills that we have, like I mentioned, are like Excel spreadsheets, Cosmos DB, SharePoint, PDF files, Word docs, but they're adding new stuff every day.
Thank you.
Yeah. But it's it's really interesting and evolving very, very fast. So I'll just throw in a couple extra slides on this if you guys want to look into it when you get the deck. Cool. All right. Well, I know you guys have a fun-filled day ahead. So enjoy your day. I will be going to bed shortly. But hopefully you enjoyed it. And thank you guys so much. And if any questions come up, you can always send them to me. And I can get back to you guys if you'd like. The last thing I'll just say is don't forget, connect on LinkedIn or on Twitter. You can follow all of the cool stuff we're going to do for AI and build. And Azure, we have 2 Azure MCs that are going to be covering all of the sessions for Azure and AI. So it'll be you'll get a lot more content than, of course, would be available. And some people even say it's a better than even going by yourself, because you're able to see so many more sessions and even get one-on-one interviews with some of the people that are going to be speaking. So it'll be fun. So hopefully I'll see you guys online, and thank you again for having me.
All right. Thank you so much, Noelle. Thanks for making your time.
Yes.
Yeah, looking forward for all the other things as well. And it had been like long journey traveling with you for Dear Azure. Thank you so much for your contributions.
Yes, absolutely. My pleasure. Thank you very much.
Yep. Thanks, here. Bye-bye.
Yep. Bye.